part of the issue of using the chain rule is recognizing when you actually do have a composite function. That's brought into the largest focus when when the inside function is actually the exponent of an exponential. The thing to recognize in this situation is that what I have is e raised to the x cubed plus 5. This means that it may not look like it, but what this means is that the outer function is e to the x and the inner function is x cubed plus 5. If you want to convince yourself of that, just evaluate it using the functions I've given. So this means f of g of x is equal to f of x cubed plus 5. Since f of x is e to the x, that means I'm going to take this x and replace it by whatever's inside there. So that's e to the x cubed plus 5. So this is a very common situation where you have to recognize the exponent in an e to the an e to the something type function is really the inside function. So now that we know what f and g are, we can write their derivatives. F prime of x is equal to e to the x, and g prime of x is equal to 3x squared. And of course, by the way, I'm using a slightly different notation here, but it really means the same thing. In the previous problem, we said h of x is equal to this function, find h prime of x. Now I'm just kind of doing it in line by saying, using this notation d over dx, which means find the derivative of the function that's after that. So I'm really being asked to do the same thing. Anyway, continuing with this problem, we know that d over dx e to the x cubed plus 5 is going to equal, as I've defined f and g, is going to equal f prime of g times g prime. So that's going to equal f prime of x is e to the x, so I'm going to take e to the x, and inside I'm going to put, instead of putting x, I'm going to put g. G is x cubed plus 5. And then I'm going to multiply it by g prime, which is 3x squared. So cleaning this up a bit, that's 3x squared e to the x cubed plus 5.